Hello, my dear learner. You are welcome to the fifth lesson in our SHS2 Core Mathematics program. This program is brought to you by the Center for National Distance Learning and Open Schooling. My name is Gershon Awudi. You remember in year 1 of this program, we learned how to draw linear graphs. Yes, we did that by constructing table of values, plotting ordered pairs on a graph paper, and joining the points to form straight lines. In today's lesson, we shall extend our knowledge to situations that involve two simple linear equations known as simultaneous equations. That's right. That is the topic for today's lesson. Simultaneous linear equations. What are they? Simultaneous equations are two equations with two unknown variables. For example, x and y. They are called simultaneous because the two equations must be solved at the same time. And the solutions to the simultaneous equations must be true for both equations. For example, in the equations x plus y is equal to 10, and x minus y is equal to 2. X and y are the two unknown variables. So to solve these equations simultaneously means that we must find two numbers whose sum is 10 and whose difference is 2. The numbers clearly are 6 and 4. That is to say, 6 plus 4 is equal to 10 and 6 minus 4 is equal to 2. That is great. We shall solve simultaneous equations by the graphical method, substitution method, and the elimination method. But today we shall pay more attention to the first part, that is, solving simultaneous equations by using graphs. We shall do this by plotting the two linear equations on the same graph by using the intercept on both axes or drawing table of values. Then we locate the point of intersection between the two lines. The point where the two lines meet, the point of intersection, is the solution set of the two equations. I hope that was clear. Let me show you how to solve simultaneous equations using the intercepts. Solve these linear equations simultaneously using graph. X plus y is equal to 2 and x minus y is equal to 6. To solve for x and y, let us find the intercept on both axes. That is, when x is equal to 0 and when y is equal to 0. For the first equation, which is x plus y is equal to 2, when x is equal to 0, then we have 0 plus y is equal to 2. And that gives us y is equal to 2. So one point on the line is given by 0, 2. Also, for the same equation, when y is equal to 0, then we have x plus 0 is equal to 2. And that will give us x equal to 2. Another point on the line is 2, 0. That is when x is equal to 0, y is equal to 2, and when x is equal to 2, y is equal to 0. So we draw a straight line through the points. Now, for the second equation, which is x minus y is equal to 6, we also let x equal to 0. And then we solve for y. So when x is equal to 0, we have 0 minus y is equal to 6. And that will give us y is equal to negative 6. So we have another point on the line being 0, negative 6. Also, for the same equation, when y is equal to 0, we have x minus 0 is equal to 6. And that will give us x equal to 6. And so on that line, we have 6, 0. The straight line through the point 0, negative 6 and 6, 0 is shown on your screen. So the two equations, x plus y is equal to 2 and x minus y is equal to 6, are linear equations, and on the same graph sheet will appear like this. Look at where the two lines meet. This is awesome. They meet at x equal to 4 and y is equal to negative 2. From the graphs, the point of intersection of the two lines is 4, negative 2. Therefore, the solution set of the two equations is x equal to 4 and y is equal to negative 2. Shall we take a look at another example? This example involves using a table of values, so we'll see how this is done. Using a scale of 2 centimeters to 1 unit on the x-axis and 2 centimeters to 2 units on the y-axis, draw the graphs for the straight lines y plus 2x is equal to 1 and y minus 3x is equal to 11 on the same graph sheet. Using your graphs, find the truth set of the simultaneous equation y plus 2x is equal to 1 and y minus 3x is equal to 11. To solve this question, we have to draw a table for the two equations. We now have to choose values for the table. But let us take numbers from negative 2 to positive 2, because these are very simple numbers to deal with. So for the equation y plus 2x is equal to 1, when x is equal to negative 2, we have y plus 2 times negative 2, and that should be equal to 1. So y minus 4 is equal to 1, and solving, we have y is equal to 5. Also, when x is equal to negative 1, we have y plus 2 times negative 1, and that should be equal to 1. And so we have y minus 2 is equal to 1. So y is equal to 1 plus 2, which is equal to 3. Next, when x is equal to 0, we have y plus 2 times 0, and that should be equal to 1. And that will give us y is equal to 1. When x is equal to 1, we have y plus 2 times 1, and that should be equal to 1. And we have y plus 2 is equal to 1. When we solve that, we have y is equal to 1 minus 2, which is equal to negative 1. Finally, when x is equal to 2, we have y plus 2 times 2, and that should give us 1. So we have y plus 4 is equal to 1. And y is equal to 1 minus 4, which is equal to negative 3. I believe that was simple. For the second equation, which is y minus 3x is equal to 11, when x is equal to negative 2, we have y minus 3 times negative 2, and that should be equal to 11. So we have y plus 6 equals 11, and that will give us y is equal to 5. Next, when x is equal to negative 1, we have y minus 3 times negative 1, and that should also be equal to 11. So you have y plus 3 is equal to 11, giving us y is equal to 11 minus 3, which is equal to 8. The next is 0. When x is equal to 0, we have y minus 3 times 0, and that should be equal to 0. And y is equal to 11. When x is equal to 1, we have y minus 3 times 1, and that should give us 11. So we have y minus 3 is equal to 11, and then we group like terms, y is equal to 11 plus 3, which is equal to 14. Finally, when x is equal to 2, we have y minus 3 times 2, and that should give us 11. And so we have y minus 6 should be equal to 11. And so solving, we have y is equal to 11 plus 6, which is equal to 17. Now, with our tables ready, we draw the graphs of the two equations as shown. you can see that where the two lines meet, that is the solution set. So from the graph, the point of intersection is -2 and 5. That is x equal to -2 and y is equal to 5. Therefore, the truth set of the simultaneous equation is x, y, such that x is equal to -2 and y is equal to 5. Let us try another example. On the same axis, draw the graphs of the equations y is equal to 2 minus x and y is equal to x minus 4 in the range 0 is less than or equal to x, less than or equals to 4. That is, x is from 0 to 4 inclusive. Hence, find a value of xy which satisfies both equations at the same time. Now, since we are given a range from 0 to 2, the best thing is to draw a table of values for the two equations. So let us try to draw the tables for the two equations. Note that the simultaneous equations are given as y is equal to 2 minus x and y is equal to x minus 4. For the first equation, y is equal to 2 minus x, when x is equal to 0, we have y is equal to 2 minus 0, and that will give us 2. Also, when x is equal to 1, we have 2 minus 1, and that will give us 1. The next is 2. When x is equal to 2, we have y is equal to 2 minus 2, and that will give us 0. And when x is equal to 3, we have y is equal to 2 minus 3, which is equal to -1. And finally, when x is equal to 4, we have y is equal to 2 minus 4, and that will give us -2. We also have to consider the second equation, which is y is equal to x minus 4. So when x is equal to 0, we have y is equal to 0 minus 4, and that will give us y is equal to -4. The next is 1. When x is equal to 1, we have y is equal to 1 minus 4, which is equal to -3. Then also, when x is equal to 2, we have y is equal to 2 minus 4, which is equal to -2. And when x is equal to 3, we have y is equal to 3 minus 4, which is equal to -1. And finally, when x is equal to 4, we have y is equal to 4 minus 4, which is equal to 0. Lovely. The graphs of the two equations are shown on your screen. Where the two lines meet at x is equal to 3 and y is equal to -1. From the graph, the value of xy, which satisfies both equations at the same time, is given by 3, -1. This is the point of intersection of the equations. Shall we take a look at another example? On the same axis, draw the graphs of the equations q plus 2p is equal to 4 and q is equal to 2p. In the range 0 is less than or is equal to p, which is less than or equal to 5. And we are supposed to make the p axis horizontal and find the solution of these simultaneous equations. Now, we are given the range from 0 to 5. So we take values of p from 0, 1, 2, 3, 4, and 5, and find their corresponding q values. So for the equation q plus 2p is equal to 4, when p is equal to 0, we have q plus 2 times 0, which is equal to 4. And that will give us q is equal to 4. Also, when p is equal to 1, we have q plus 2 times 1, and that should give us 4. So we have q plus 2 is equal to 4, which is q is equal to 4 minus 2. And that will give us q is equal to 2. When p is equal to 2, we have q plus 2 times 2. And that should be equal to 4. So we have q plus 4 is equal to 4, giving us q is equal to 0. I'm sure you can follow the trend. So the next value of p is 3. So when p is equal to 3, we have q is equal to 4 minus 6, and that will give us negative 2. The next value is 4. P is equal to 4, and q plus 2 times 4 is equal to 4. And that will give us q is equal to 4 minus 8, which is equal to negative 4. And finally, when p is equal to 5, we have q plus 10 equals to 4. And that will give us q is equal to negative 6. Great. Now, shall we consider the second equation, where we have q is equal to 2p. When p is equal to 0, q is equal to 2 times 0. So that is equal to 0. So if you look at the equation carefully, we are multiplying the values of p by 2, and that will give us q. So I want you to do that quickly as you move along. When p is equal to 0, we have q is equal to 2 times 0, which is equal to 0. And when p is equal to 1, we have q is equal to 2 times 1, which is equal to 2. Also, when p is equal to 2, q is equal to 4. When p is equal to 3, we have q is equal to 6. When p is equal to 4, we have q is equal to 8. And finally, when p is equal to 5, q is equal to 10. Now, the graphs of the two equations are shown on your screen. And as you can see, the two lines meet at p is equal to 1 and q is equal to 2. Therefore, our solution is 1, 2. Great. Shall we take the final example on this type of simultaneous equations using graphs? Solve the equations 2x plus y is equal to 7 and y is equal to x plus 1 simultaneously using graphical method on the interval negative 1 is less than or is equal to x, is less than or is equal to 8. Again, we shall draw a suitable table for the two equations. So let us work for the values for our table. Now we have x, y is equal to 7 minus 2x for the first equation, and then y is equal to x plus 1 for the second equation. What I'm going to do is that I'll mention the x values, and then you provide the values for y for the two equations. So let's start. When x is equal to negative 1, for the first equation, y will be equal to 9. Good. Also, when x is equal to 0, we have y is equal to 7. When x is equal to 1, we have y is equal to 5. When x is equal to 2, y is equal to 3. When x is equal to 3, y is equal to 1. When x is equal to 4, y is equal to negative 1. And when x is equal to 5, we have y is equal to negative 3. Can you continue from 6, 7, and 8? I hope you are finished by now. When x is equal to 6, for the first equation, we have y is equal to negative 5. And when x is equal to 7, we have y is equal to negative 7. And finally, when x is equal to 8, we have y is equal to negative 9. For the second equation, y is equal to x plus 1. Let's see how You can do that. I'll give you the values of x, and you provide the corresponding values of y. Let's go. When x equals to -1, we have y is equal to 0. Excellent. When x equals to 0, we have y is equal to 1. And when x equals to 1, y is equal to 2. Remember, we are just adding 1 to the x values. So when x equals to 2, we have y is equal to 3. When x equals to 3, y is equal to 4. X equals to 4, y is equal to 5. You are right. When x equals to 5, y is equal to 6. When x is equal to 6, y is equal to 7. When x is equal to 7, y is equal to 8. And finally, when x is equal to 8, y is equal to 9. Good work done. So what you have to do is to draw the straight lines with our x and y values and find their intersection as our solution set. And as you can see from the graph, the intersection is 2, 3. Hence, the solution of the simultaneous equation is x is equal to 2 and y is equal to 3. We can see that this is very easy to do. What we are required to do is to draw the table for the range we are given. Then we choose a good scale and plot the points. After this, we join the points to form a straight line. Now, I want us to take a quick look at what you have done so far. In this lesson, we studied how to solve simultaneous equations using graphs. And we said the truth set for a pair of simultaneous equations is the set of values which make both equations true. We also said when solving simultaneous equations using graphs, we need to find the values of the two unknowns, for example, x and y, and draw the lines for the given equations. We also said the points where the two lines cross or meet is a point of intersection, and that is the solution set of the equations. Well, this brings us to the end of the first lesson on simultaneous equations using graphs. Join us again for further work on simultaneous equations, where we shall be looking at solving simultaneous equations using the substitution method. Till then, bye.